In this video, we're going to learn how to write a MacLaurin polynomial for sin x. Now, MacLaurin polynomial for sin x is one of the ones you're going to want to memorize. You're going to want to memorize sine, cosine, and e to the x. So keep that in mind as we move along. So the first thing we do is we have our function f of x is sine of x, and we're going to start taking some derivatives. So the derivative of sine is cosine. The derivative of cosine is negative sine. The derivative of negative sine is negative cosine. And the derivative of negative cosine comes back to sine. Now I did several of these so that we can go ahead and see what happens, because it does say non-zero terms. Now a MacLaurin polynomial by definition is centered about x equals 0. So we're going to start off by plugging in zeros. So f of 0 is sine of 0, which is 0. Well, we can't use that term because we need non-zero terms. If we do f prime of 0, we get cosine of 0, which is 1, so we can go ahead and use that. F double prime of 0 is negative sine of 0, which is back to 0, can't use that. F triple prime of 0 is negative cosine of 0, which is negative 1, that one's good. If we come back now, obviously the fourth derivative at 0 is going to be 0 because we're back to sine x. So now we're back to a pattern. So our next derivative, our fifth derivative, would be cosine of x, and our fifth derivative at 0 would then again be 1. Well, now we have 1, 2, 3 non-zeros. So I am going to go ahead and show all the terms on the first step. So typically we would start off and we would have 0 as our constant term. Then we would have 1. Now it's about 0. So we don't really need that 0, but I'm going to go ahead and show it initially. We then have a 0, and that would be our x minus 0 squared term. Then we have a negative 1. Of course, that's over 2 factorial. Then we have a negative 1, x minus 0 cubed over 3 factorial. And then we have another 0, x minus 0 over 4 factorial. And then we have a positive 1, x minus 0 to the 5th over 5 factorial. If we get rid of all the 0 terms because we need non-zero terms, then what we're left with is 1x minus 1x cubed over 3 factorial plus 1x to the 5th over 5 factorial.